All right, welcome to day 2. I'm going to start off with a question from yesterday dealing with the idea of solving a trig equation. I'm going to start off with a review idea of, let's say that we had 3 plus the square root of x is equal to, say, 4. Well, remember that anytime you have a radical equation, one of the things that you would want to do is to isolate the radical and then square both sides, okay? All right, so if we apply that to our example over here, we have, if I add the radical over, 3 cosine of x is equal to the square root of 3 plus 5 cosine squared x. Now I can square both sides. Big thing that you have to remember on the left is make sure that you square the 3 and the cosine so that you get a 9 cosine squared x equal to 3 plus 5 cosine squared x. Next, you want to think about combining like terms, so I'm going to subtract the 5 cosine squared over and get 4 cosine squared x is equal to 3. I'm going to divide by 4 and get cosine squared x is equal to 3/4. And then from there, I'm going to take the square root of both sides, and remember I need a plus or minus when I do that. And so I'm left with cosine of x is equal to plus or minus square root of 3 over 2. All right, so concept that we have to be aware of is you have 4 possible values. X can equal a pi over 6. It can be a 5 pi over 6 from the second quadrant. It can be a 7 pi over 6 from the third quadrant. And it can be an 11 pi over 6 from the fourth quadrant, because remember we're looking for positive root 3 over 2 and negative root 3 over 2. All right, but there are extraneous solutions here. If I were to plug the negative ones back in, well then that would mean, if I think about like right here, then I have 3 times a negative number, which gives me a negative result on this side. And when I take the square root, now the negative was going to be squared and become positive, but when I take the square root, I'm going to get a positive. Since a negative can't equal a positive, I have to throw these 2 answers out. So therefore, x is equal to pi over 6 and 11 pi over 6 plus 2 pi. Okay. So just be aware, make sure that you're checking your answers to see if they work. All right. Numbers 2 through 4. Concepts here are going to deal with the end of our lesson yesterday. Just understand that sometimes when you go to do your inverse function, you get a negative answer. Well, we want positive answers only. And so if you see this right off the bat, x is going to equal sine inverse of a negative 0.72, which is roughly a negative 0.8. Okay? Well, negative 0.8 is not between 0 and 2 pi. If need be, think about a sketch, okay? So negative 0.8 would go this direction, but I want a positive angle measure, so I need to go this direction. So therefore, my x value is going to be a 2 pi minus a 0.8 or plus a negative 0.8, which gives me an x value of let's see, 6.2 minus 0.8, what is that, like 5.49 roughly, okay? And then remember that sine is symmetric across the y-axis, so therefore there's another angle over here that is also going down by a value of negative 0.8. So if I want its angle measure, I have to do pi plus a positive 0.8, because I'm adding 0.8 onto my pi, and so I should get x is equal to a 3.94. So here are my 2 angle measures. My big suggestion always think about just making a little sketch, and it kind of puts it in perspective in terms of, well, do I subtract from 2 pi, do I add pi, etc. All right, in example 3, you're going to do cosine inverse of negative 0.22, okay, and you are going to get an x value of 1.79, which is fine, okay, because that is between 0 and 2 pi. All right, so I'm going to just make a little sketch. So 1.79 gets us to here, okay. Cosine is symmetric across the x-axis, where sine is symmetric across the y-axis. So remember that that's also 1.79 this direction. So one of the things that we can do in order to get this second angle measure is we can do 2 pi minus 1.79 to get our second x value, which is roughly x is equal to 4.94. Okay, moving on, third example here. Always think about factoring first anytime you have a squared function and a non-squared function. So it looks like a trinomial here. Two numbers that multiply to be negative 35 and add to be negative 2 are negative 7 and 5. So I've got tangent of x minus 7 times tangent of x plus 5 is equal to 0, which means that tangent of x is equal to 7 and tangent of x is equal to negative 5. X is going to equal tan inverse of 7, and x is going to equal tan inverse of negative 5. Okay? All right, when I get those values, okay, for the first set, for the tan inverse of 7, I'm going to get an x value of 1.42. Now remember, since it's tangent and it's symmetric across the origin, if we've got 1.42, well then I'm going to add pi to get the other one. Okay, so I've got x is also equal to pi plus 1.42, or x is equal to 4.57. And when I go to do the tan inverse of negative 5, I've got a x value equaling a negative 1.37, which is not between 0 and 2 pi. So when I make my little sketch and I have my angle going this way by a value of negative 1.37, that means I'm going to do 2 pi minus it to get the positive result. And so x is going to equal a 4.91. Reminder that it is symmetric across the, symmetric across the origin, so the other one is going to be a value of pi less, or negative 1.37 plus pi, however you want to look at it. So if you want to do negative 1.37 plus pi, you'll get the other value of 1.77. Okay. Otherwise, you could also have done 4.91 minus the 1.37. You'll get the same thing. Okay. All right, page 2. Okay, one of the first things I need you to notice is the directions talk about finding the solutions that are on the interval from 0 degrees to 360 degrees. So the first thing you're going to have to do is change your mode on your calculator to degrees versus radians. Otherwise, it's not going to work. Okay. Otherwise, we've practiced this a little bit already. You are going to do the cosine inverse of 1/4 on your calculator. Hit enter, and you should end up with, if we round to 1 decimal place, 75.5 degrees. All right, reminder, okay, since we're talking about cosine being a positive value, cosine is positive in the first quadrant, which is what you're seeing right now, because we're getting a 75.5 degrees. Okay, but cosine is also positive in the fourth quadrant, which means that we need to go 75.5 degrees this way. But since we want a positive angle, that means that we need the angle that is roughly 360 degrees minus the 75. So 360 minus the 75.5 degrees gives us our second angle at 284.5 degrees. Okay, so remember that this value tells us, kind of interprets what quadrants we're looking for our values. Okay, so to kind of piggyback off of that, notice that our cotangent is negative. Well, when is tangent and cotangent negative? Tangent and cotangent are negative in the second and the fourth quadrant. So both of our answers are going to be in the second and fourth quadrant. All right, so how do you do a cotangent? For this one, you are going to do tan inverse of 1 divided by negative 0.286. So you always have to do the 1 divided by whatever the value is whenever it's a secant, a cotangent, or a cosecant. All right, if you hit enter on this, you should end up with negative 74 degrees. All right, reminder that we want the interval from 0 to 360 degrees, which means that we don't want the negative value. All right, so I like to have pictures. Pictures help us a lot. So if our angle is going negative 74 degrees this way, well, then that means I need to do 360 minus the 74, which gives me a 286 degrees. Okay, we talked about how cotangent is also going to be negative in the second quadrant, which means that I have to take my 286 degrees and I have to subtract 180 degrees. So if I do 286 minus 180, I'll end up with the angle that's in the second quadrant, which is roughly 106 degrees. Technically, we should say like 0.0 and 0.0 based upon rounding, like 74.0. I just rounded to the whole number because they were like 105.96. Okay. All right, in the seventh example here, you have a situation that is not factorable. So one of the things that we got to think about doing is using the quadratic formula. Now, since we're talking about, x, sine of x, we have to use sine of x with our quadratic formula. If you need to, reminder, you can always use the idea of u is equal to sine of x. But I'm just going to go directly to sine of x is equal to the opposite of b. The opposite of b in this case is 1, plus or minus the square root of b squared, so negative 1 squared, minus 4 times my a value of 1 times my c value of negative 1, all divided by 2 times a. This gives me sine of x is equal to 1 plus or minus the square root of 5 divided by 2. Okay, so that gives us two values. Sine of x is equal to 1 plus root 5 divided by 2. Now, if I figure out the decimal value for this, it's roughly 1.62. But remember, the range for sine of x is any value that goes from negative 1 to 1. And since this does not fit in that, that means that we cannot use this. This is not a possible solution. Okay, so then we go and find sine of x equal to 1 minus root 5 over 2, which is sine, just this value is roughly negative 0.62, which means that we're looking for a value that is in either the third or the fourth quadrant. So when we do sine inverse of our 1 minus root 5 over 2, we get an answer of approximately negative 38.2 degrees, okay, which makes sense because it's in the fourth quadrant. But remember that we don't want a negative angle, okay, we want the positive angle. So the one thing that we're going to have to do is do 360 minus 38.2, and that is going to give us a 321.8 degrees. All right, so that gives us the angle that is in the fourth quadrant. So to get the one that is in the third quadrant, we have to understand that if it's 38.2 degrees this way, it's also going to be 38.2 degrees this way, which means I need 180 plus my 38.2, giving me my second angle at roughly 218.2 degrees. So here are my two values. Okay, remember I had to change the negative 38 to a positive, and then I had to do 180 plus the 38.2. All right, last example here. All right, so this one we could probably do without a calculator. If you think about when is sine equal to 1/2, hopefully 30 degrees pops into your head. If you need to use your unit circle, 150 degrees is also the other situation, because remember sine is positive in both the first and the second quadrant, so there's two possible answers here. All right, but we want to find all of the angles that this occurs to, and so because of this situation in which our period length is changing, this affects how many values we have. We are going to have 3 times as many, and I'm going to show you how to get that. So if you recall, what we did yesterday was we said that all of our angles, 3 of x, is equal to 30 degrees, and then we would have said like plus 360k. Well, since I want to solve for x, I'm going to divide by 3, and if I divide the left side by 3, I have to divide the right side by 3. So that tells me that x is essentially equal to 10 degrees plus 120k. All right, let's do the 150 as well then. All right, so if 3x is equal to 150 plus 360k, and I go and divide by 3 again, well then I've got x is also equal to 50 plus 120k. All right, so now I gotta plug in values of k. I'll start with 0. Well, if that is true, then x is equal to 10 plus 120 times 0, which is equal to 10 degrees. X is equal to 50 plus 120 times 0, which is 150. Sorry, not 150, 50 degrees. Okay, if k is equal to 1, then x is equal to 10 plus 120 times 1, which is 120 plus 10, or 130 degrees. X is equal to 50 plus 120 times 1, which is 170 degrees. If k was equal to 2, then x is equal to 10 plus 120 times 2. 240 plus 10 is equal to 250 degrees. X is equal to a 50 plus 120 times 2, or 240 plus 50 is 290 degrees. If k is equal to 3, then x is equal to 10 plus 120 times 3, which is 360 plus 10, which is 370, which means since it's no longer in that range, remember we wanted from 0 to 360, this is now out of it, so I can cross that one out. And just to check with the other one, I already know that it's not going to work. 50 plus 120 times 3, 360 plus 50 would be 410. Okay, and I can throw that one out as well. All right, so that means that x is equal to 10 degrees, 50 degrees, 130 degrees, 170 degrees, 250 degrees, and 290 degrees. All right, so anytime that you have a period change like you see here with the 3x, you got to create an equation, and then you have to divide by that value in front of the x in order to come up with your new equation, and then you have to plug in values of k until you can find all of the possible angles that work with our limitation of 0 to 360. I hope this helps. If you still have questions, please feel free to come in and ask.